Welcome to design patterns. The first pattern I want to discuss is strategy design pattern. So, strategy design pattern is a behavioral design pattern. It comes under this. We have three design patterns. So, in that behavioral design pattern, this is a subdivision that is strategy design pattern, and the definition of it is a strategy design pattern is a design pattern that allows you to define a family of algorithms or behaviors, put each of them in a separate class, and make them interchangeable at runtime. This pattern is useful when you want a dynamically change in behavior of a class without modifying its code. So, basically, why this problem has come and why this design pattern we are applying is, so design pattern we generally apply for a pattern we apply for a particular problem, and we repeat this so that that problem doesn't occur, and there are solid principles, and to use the principles and give a better code we use design patterns. So firstly, now basically design pattern, this especially strategy design pattern, doesn't allow you inheritance. Not allow you, it avoids inheritance. It tells inheritance makes the classes tightly coupled, and that increases the hierarchy of the things and complexity, so you have to avoid it. So an example for that is, now we have a example, we have a shopping cart or something where you do payment with an UPI or a card. So you have different methods, right? So now example, if you pay using UPI, and this is example we use card. So main shopping cart can be done with UPI or with card. So main class we can take, and you can inherit and implement the methods using either UPI or card. And now example, there is a discount. Now example, there is no discount, there is a festival discount or royalty discount. So now for each of this, now you have to implement with UPI and this discount. So the hierarchy increase. So for the card and for the UPI and for each of the discount, you have to implement again three classes, and you have to inherit this card with card, then I also implement three discount types. Now example, along with UPI and card, you want to separate credit card or debit card, or you have to add another payment method, you have to increase the tree. So there will come other tree here, and for each payment type again the discounts will come, and if you want to increase discount for everything, you have to add. So this is making the things tightly coupled. So this is the disadvantage of this. So we have to make this flatten like this. So how do we do, and when do we use this strategy pattern is, now you have multiple ways of doing the same task. Now I give payment example, so where we do payment with different types, or example file compression. We do either it's a zip file or any other var, or this compression techniques which we use. So either if we save a file in PNG or JPG or this different types, so we are implementing the same thing but in a different ways, right? Different methods. Now either it's a card or it's a UPI or in other payment method. So if we are performing multiple ways in doing the same task, then instead of you can avoid this large if else loop, like if this then this. Instead of that, you have to separate the classes. So that's what strategy design pattern does. And mainly this was causing, like the hierarchy thing was causing issue in open closed principle. So we have solid principle, that open closed principle, it was causing issues. So to avoid this, we use strategy pattern. Open close is generally for, so you have to be open for extension, not modifying of the code. If there is already inbuilt code, you don't modify the inbuilt code, you extend it, use it, so you don't spoil the main code. That is what open or closed principle tells. So what exactly and how exactly strategy pattern works is this one. So we have context, client, concrete strategies, and strategy interface. So let me come with the interface. Firstly, we will write an interface. Where now example here in this GFG website, where you see they have implemented sorting. So sorting is a method, and we are doing sorting. The task is same, but we are implementing different ways to finish the task, right? So that's what. So we can use bubble sort, quick sort, merge sort. So first we can create an interface. The main sorting strategy which we are doing, we create an interface and implement this method sort. Okay, so that is what the interface doesn't have the implementation. So that is what the strategy interface is. This part, strategy interfaces, where we just write the interface. Now coming to the concrete strategies. So concrete strategies are the exact tasks, exact ways that we are implementing that task. Now we can do it bubble sort or merge sort or quick sort, any method we can do. So we implement the interface using these strategies. So for bubble sort, we just implement we'll just implement the sorting strategy and the method which we do, and the actual implementation will be written here. Here they just give the print statement. Here you can actually write the bubble sort. So the implementation of the interface is done in the concrete strategies. So how many ways are there? That many ways. Now you have UPI or card. So all these strategies comes in the concrete strategy. Now this is the concrete strategy. Coming to the context. So context is basically the bridge between the client and these strategy implementation. So basically this here in this concrete strategy, we inject the task. So we basically, client actually chooses this in the runtime. Basically all the strategy design pattern is choosing what strategy you have to implement in the runtime. Instead of doing it in a compile time, whenever we want, client will pass the strategy and that strategy will be separately implemented. So the client given strategy will be injected to context, and context pick the strategy, basically that will be implemented. So when I tell the definition of this, so here if you see, context is a class or object known as a context that assign the task to a strategy object and contains a reference of it. So basically we have task, so this will basically assign. Now if you want to perform merge sort, that will give it to merge sort. If it is a quick sort, it will give it to quick sort, and the reference of all this will be contained in the context, and it serves an intermediate between the client and the strategies, offering an integrated approach for a task execution without exposing the details. So it doesn't expose the details, you don't know what is happening inside it, and it acts as intermediate and maintains a reference to a strategy object and calls it method to perform the task. So basically that calls the method and performs the task and allow for interchangeable strategies. So you can interchange this. So if you see the context, that will make more sense. So now if you see sorting strategy, and we have the sort method, and here we have done the injection, dependency injection. So firstly we took the sorting strategy and we did constructor injection and we just assign. This is setter injection, and here also we have done the same thing. and perform sort. This is the method that actually implements the sort using the strategy. So here we are doing all the injections and here we are performing this. So this context is basically creating a middle layer, so that is actually performing the thing. So it chooses the basically, yeah, it assigns the task to that strategy object. We have the task and strategy object, so it assigns for which it is doing. So this creates the abstract layer for that. So the context we have here, and that is how it is implemented. So as you go to the entire code of it, now and the last part, the client, where we choose it in the runtime, right? So this was the interface part, and these are all the concrete strategies: quick merge and bubble sort, and the sorting context where we do all the dependency injections. Here the sorting context, this is a constructor injection which we have done, this is a setter, and this where we actually perform that, where we assign the particular task here. Now in the client, so in the main method, if you go, first we get the sorting context and we create object of it and we pass the strategy. So here if we want to do bubble sort, we pass the bubble sort strategy, then we create an array and the perform sort. So in the context we already passed the strategy, so for this strategy we have to implement this task. So for the bubble sort strategy we are implementing sorting using this array, that's what we are assigning. So that's what it is happening. Now we can change the strategy. See, we get the context, and set is using here they created object and pass strategy. Here using setter, they are passing the strategy and say performing the task, again setting the strategy and performing the task for that strategy. So the context is allowing the interchangeability. So based on that, whatever you call, that strategy will be implemented. That's all. So if you wanna see this in a UML diagram, so this is the class diagram that implements it. So UML is like better HLD representation of all the classes and the relations between them. Now we have a sorting context. This is the sorting context, and this is the sorting strategies, and these are the concrete strategies, and this is the client. So now minus indicates the private. If I show the sorting context, it will make more clear. Yeah, so this was the sorting context, and the sorting strategy which was private, minus indicates this is a private class, and these three are the public. So first we injected through a constructor injection, this setter, and this is a perform sort where we are doing method. So these are three public, plus indicates the public, and hashtag indicates the protected. So this is a sorting context class, the box indicates the class, and the upper box indicates the attribute. These are the implementation methods. So the relation between sorting strategy and the context is given by this arrow. So what does the diamond arrow indicates is aggregation. Diamond means the whole part. So if you go to the definition of it, aggregation is a specialized form of association that represents the whole part relationship. It denotes a stronger relationship where one class, the whole, contains or is composed of another class. Aggregation is represented by a diamond symbol on the whole class, and this can independently exist. So basically this is the interface and this is the injections happening. So this is the whole part relation. So this exists, this whole is existing in this, right? Because without that interface this doesn't come. So this is the whole part association between them. And next, coming to dotted lines, which is dotted lines with this arrow, and this is realization. So when we do an interface implementation, that is a realization. So realization indicates a class implements the features of the interface. It is often used with the class realization, defined by interface. So the interface implementations of this is realization. Is that the so we denote with this arrows, dashed arrows with this thing. And coming to dependencies, this dotted with normal arrow is the dependency, and dependency exists between two classes when one rely on another, but the relation is not strong as inheritance and it is loosely coupled. The main point of strategy design pattern is loosely coupling. So the client is loosely coupled to this. It is attached, there's a connection, but it is loosely, because independently we can implement each sorting, right? We can use this sorting algorithm somewhere else. So this is dependency and this is direct association. The client is directly associated to sorting context. So the deeper of these indications are given in this. So this is how it proceeds: context, client, concrete strategy, and strategy interface. These are the components of strategy design pattern. So we can see other example also where I told about credit card and UPI. Now if we take payment as a strategy, and that is an interface which implements pay. So credit card you can implement or using UPI. These are the concrete strategies and this is the interface. And context class. So context class using constructor injection, you can do this, and this is the method where we inject. So here we assign the task for this in this context class, and in the main we give which. So now payment strategy example, UPI payment is the object that is created. So in the shopping cart we pass this strategy, this is injected here, and using that strategy the method is implemented. We can either switch the strategy, same shopping cart, now using credit card, and do the checkout, implement the same checkout with this. So this is normal manual constructor dependency injection. If you are using Spring, then you can use this auto wire directly, and we use application context and run with the Spring application and use context pins. That's all. So now coming to what are the challenges that we face without this is there is no flexibility. In inheritance we don't have flexibility, and code we have to duplicate, we have to implement, and it is implement the same methods, right? If we are inheriting the methods which we take in the parent class, we have to implement them. So again the code duplication occurs and it is hard-coded logic. So strategy design pattern solves this. So code reusability will be, there will be flexibility and extensibility and separation of classes. We can separate the classes. So this is an overview of strategy design pattern and two examples where we have sorting algorithms or credit card payment, and we can use in compression techniques, all this. So when we are performing a same task using multiple methods, it's better to use strategy design pattern. That's all. Thank you.